Good day to Doctor and my team member. I am Balarajan Sanasi. Will present about introduction and part of the software analysis for this Engineering Mathematics 5 project. Let's begin. Then I will present about analysis of 100 real data in SPSS software. From here we can see this is a SPSS software. So our chosen 100 real data consists of time and power. The time, which is independent variables, and the active power in kilowatt, which is the dependent variable, consists of 100 real data from 0 to 99 minutes. Then we also performed statistic analysis in Microsoft Excel software, which is to analyze the scatter plot of active powers time, also defined as scatter diagram and regression line for the 100 of real data, which is time and power. The computed mean, variance, standard deviation, and minimum and maximum value in XPSS same as the Excel software output. And this is the first part before compute the scatter diagram and regression line model. Finding simple line regression model by using least square method, hypothesis test, and lastly compute the coefficient of Pearson correlation and determination. After that, for the graph of scatter diagram and regression line, this equation represents the regression line for this scatter plot. From this equation, we can obtain the intercept, which is 2.57, and the slope, which is negative 5.67 power of negative 4 for this regression line model. Then, to identify the correlation, we can R-square the value of 0.063. Besides, we also obtain the same regression line equation and R-square values in Microsoft Excel software for the scatter diagram and regression line model. That's all for me. Then I will pass next presentation to my team member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhida Najwa binti Shardin and my metric number is AE190039. I'm going to explain this part. Assuming a linear relationship, use the least squares method to find the simple linear regression model. So first, after we already insert all the data and find the mean and standard deviation and also the scatter diagram, we click analyze, regression, and linear. And then as we can see here, the dependent variable is active power and independent variable is time. Okay, so this is what we get for the regression. So all the table below shows the data needed to obtain the simple linear regression. So table 3, variables entered or removed table. Table 3 shows the information about the variables used in order to predict the variables. In the table stated the dependent variable y and independent variable x, which are active power and time. So dependent variable is active power and independent variable is time. Table 4 is model summary table. Table 4 shows the simple correlation R and the total of variation in the value of active power in kilowatt R square. The R square value is 0.063, which means 6.3% of the total variation in active power Y can be explained by the linear relationship with independent variables, which is time X. Table 5 is ANOVA table. Table 5 is ANOVA table which indicates the significance and worthy of the model. From the table 5, we can see the significant value is equal to 0.012, which is less than 0.05. Based on the significant value, we decided to not reject HO and assume that beta 1 is equal to 0. Next is assuming a linear relationship, use the least squares method to find the simple linear regression model in 4.13. So here is the table. Table 6, coefficients table. In table 6, it shows that The equation of regression line is y equal to negative 0.01x plus 2.569 based on the value b of unstandardized coefficients. From the regression line equation, we can state that the slope is time, which is negative 0.01, and the y-intercept is constant, which is 2.569. In order to determine the significance of the slope, we must see the significant value in the table above. The significant value is less than 0.05, which makes the slope is significant. Thank you.
Assalamualaikum, my name is Ninur Agilah. So today I will continue on the interpret the meaning of the intercept and slope in this problem. The simple line progression model is y equal to beta 0 plus beta 1 x plus epsilon, which we can extract from the graph scatter. The y-intercept is represented by the beta 0, while the slope of the regression line is represented by beta 1. Y equal to beta 0 plus beta 1 x plus epsilon is the regression line equation, which contains independent and dependent variable. From the result above is what we got. Here is the result of beta 0 and beta 1. This is from the manual calculation, and this is from the SPSS. So from the result above, it shows that the y-intercept beta 0 from the graph are 2.569, and the result we get by manual calculating is 2.5461. Epsilon is the statistical error, which is a gap of data point to the linear line on the graph. Thus, the inaccuracy from the graph is 0.013. This is the coefficient standard error 0.013. I'm sorry. Next one is test the hypothesis whether the slope is equal to 1 against unequal to 1 by taking 5% level of significance. The hypothesis has been stated that HO beta 1 equal to 1, and the t-tests were used to compare means of two groups by taking alpha equal to 0.05. So from what we present or what we calculate is this TC equal to 1.984, meaning the value of plus minus 1.984 were taken from the statistical table of t-test. The HO will be rejected if the result does not fall on that region. And the result on the t-test we got is 16.1865. Based on the result that we got, the t-tests are bigger than TC, thus that the H0 is rejected. In the meantime, the slope hypothesis has been rejected and HO has been accepted because of the significance value is less than 0.05, which equal 0.00. The slope is not equal to 0, therefore because there is sufficient data to support this conclusion. The next one is test the hypothesis whether the intercept is equal to 0 against unequal to 0 by taking 5% level of significance. So as we can see, the hypothesis has been stated that beta 0 equal to 0, and the t-test we use to compare the means of two groups by taking alpha equal to 0.05. From what we got is TC equal to 1.984. It's the same as the above before. The value of plus minus 1.984 were taken from the statistical table of t-test. The hypothesis will be rejected if the result does not fall on that region. And for the t-test that we got, based on the result that we got, the t-tests are bigger than TC, thus that the hypothesis is rejected. In the meantime, the slope hypothesis of beta 0 equal to 0 has been rejected, and beta 0 unequal to 0 has been accepted because the significance value is less than 0.05. which equal 0, 0.00. The slope is not equal to 0, therefore, because there are insufficient data to support this conclusion.
My name is Dityan Raja. My matrix number is CE190043, and today I would like to present about how to compute Pearson correlation and coefficient of determination on SPSS. So as you can see, this is the 100 engineering data that we have used for this project. So time is an independent variable, power is a dependent variable. So let's we look into computing Pearson correlation. So first of all, we need to click this analyze button. Then we need to go to correlate, and we need to click bivariate. So as you can see, we need to move the time and power variable from left box to the right box. Then we need to click the correlation coefficient, which is a Pearson. For test of significance, we need to set into 210, and let's press OK. So as you can see, this is the data that we have obtained for this correlation. So let's we look into computing of coefficient of determination. So we need to press this button analyze, then we need to go to regression, then we need to press linear. So as you can see, for the dependent variable, we have already moved the power variable into the dependent box. For independent, we have moved time into the box. So for statistics, plot, and everything, we just set into default. Then we straight away press OK. So as you can see, this is the data that we have obtained for coefficient of determination. So this is the table that we obtained from SPSS. So let's interpret the meaning behind this coefficient of Pearson correlation. So as you can see here, this is the formula and the calculation involved in this Pearson correlation. So as you can see, we have obtained the value of negative 3.28 exponent negative 3. So the Pearson correlation coefficient is a correlation between two variables. So there is a relationship between them. The Pearson correlation is a tool for determining the degree to which two variables are related linearly. If the Pearson correlation is between 0 to 0.5, the correlation is moderate. However, if it is between 0.5 to 1.0, the correlation is strong. So we can investigate by looking into the relationship between time and stress levels by performing manual computation and proving it through the simulation. We can say for this Pearson correlation value, which is value is below than 0.5. So we can say that the correlation is very weak. So let's we look into the coefficient of determination, and let's talk about the meaning behind it. So this is the model summary that we have imported from the SPSS. So as you can see, this is the value of R square that we have calculated. So what is the meaning behind it? So the strength of association between these models and the dependent variables is shown. So as you can see, the linear correlation between the observed and model predicted value is represented by R, the multiple correlation coefficient. So as you can see, so the greater the coefficient, we can say that the more percentage will cross through the line R square, which is used to calculate the statistical analysis correctness. The R square of discharge from the table of correlation is 0.063 according to Pearson correlation. The value of R square is 0.0107 exponent negative 3 when we calculate it manually by the value of R square. So this is the this is what behind this coefficient of Pearson correlation and meaning for coefficient of determination and its meaning. So that's all for me. Thank you.